Next, we're going to look at transform faults. One of the major transform faults play a very important role of accommodating space on Earth as plates are moving. This is a look at Tibet, and you can see India in the lower left corner. India is moving northeast and pushing against Tibet. And as that happens, the Himalayas are rising up, but a lot of material is in the way and needs to be moved out of the way. And transform faults do that job. Look at these double arrows. These are areas where transform faults are moving material horizontally to make room for India continually pushing in to Asia. There are more than just these that I've shown here. Look around, see if you can see a few others. So transform faults make space. Here is a sketch of a divergent plate boundary on a sphere. And for the purpose of this demonstration, this is really exaggerated. It's a really large divergent plate boundary running the whole length of the globe. And you can see that there is spreading between the orange and green marks, and you can see the arrows showing how the plates are moving apart. But in order to accommodate that geometrically on a sphere, there have to be areas in between where the plates are sliding past each other. And these are the transform fault boundaries. Here's a very close-up view of a small piece of the ocean floor. And you can see the mid-ocean ridge system labeled as a spreading center in the upper right and in the center left. And you can at the same time see a transform fault that offsets the ridge in between. This is the most common kind of transform fault on the Earth. This is the west coast of North America. You can see the United States, Mexico, and Canada, so we've covered the North American continent on the west coast. And there's a few transform faults in here. There is the San Andreas fault, which is on land between Baja California and San Francisco, the Mendocino fracture zone, the Blanco fracture zone. These are separating pieces of a ridge system that's north of California, off of the coast of Oregon, Washington, and Canada. And also there's a huge fracture zone a little further south near Los Angeles, the Murray fracture zone, and then the Molokai fracture zone. These are relatively common in ocean ridge systems. This is the San Andreas fault. It's the most well-known transform fault to Americans because it's on land in California. It's very visible from the air. I want you to notice first the offset. This is a stream that has been offset by the San Andreas fault. It used to be continuous and it's been moved. And there is the fault itself. It's really quite visible from the air. The movement here has the top of the fault going, top of this picture going to the right and the bottom going to the left. Now, how do we define the movement direction on this kind of a fault? We call this kind of a fault a strike-slip fault, and we'll talk about strike later. You'll know why. But for now, let's just think about whether the movement is to the left or to the right. So let's say that you're standing at the orange dot and you're looking across the fault to the green triangle. Which direction is that green triangle moving relative to you? To the right, correct? Okay, now jump across the fault, stand on the green triangle, and look back at the orange dot. Which direction is the orange dot moving relative to you? To the right, right? Correct. So whichever side of the fault you're standing on, you are always going to measure the movement on this fault as to the right, and we call that a right lateral fault. There are other large transform faults on land. Around the Turkish plate and the Arabian plate is another place where you see a lot of them. We already looked at them in the Himalaya area. This is why there are very large earthquakes sometimes in Turkey or in the Arabian Peninsula or in New Zealand, another place where a transform fault comes up on land. Transform faults can cause very large and very destructive earthquakes when they're on land. Now, transform faults are not always perfectly straight. In fact, most of the time they're not. And where they bend, a couple of interesting things can happen. If you look at the left diagram here at the restraining bend, so in this case they're showing you a motion which is right lateral. The opposite side of the fault is moving to the right. In this case, that means along the bend that pieces of land are pushing towards each other, and that's going to cause a mountain range to form. And on the other hand, if you have a bend in the opposite direction, then the bend will cause the two parts of the plate to pull apart from each other, and you can form a basin. Along the San Andreas Fault, there are a couple of places where there are mountain ranges that form from pushing up. Here's one example. And there are places where there are basins formed by spreading apart, pulling apart. The Salton Sea is a pull-apart basin along the San Andreas Fault. Earthquakes on transform faults tend to be very strong. They're relatively shallow, usually less than 10 kilometers depth. There's a lot of surf shaking involved, and they can cause significant damage. This is from the earthquake that occurred during the World Series in 1989 and collapsed a great deal of the freeway system in the Oakland, California area.